Today we work with partial quotients to solve for division problems. In the Explore page of 4.5, we saw two area models, or the same area model, and how that helps us solve a multiplication problem and a division problem. And we've explored before how we use inverse operations. Similarly, if you think about addition and subtraction, they have the same relationship. You can even draw a fact family to see all the ways that particular numbers are related to one another. You can do the same for multiplication and division. So looking at the bottom area model, I'm trying to solve 36 divided by 3. And I need to find these two dimensions here, or this whole dimension here, because I will add these two numbers together at the end. Okay, so looking up here, I have to think to myself, 3 times what number equals 30? Thinking of this multiplication problem can help me solve. I can also say 30 divided by 3 equals what number in order to find that dimension, and the answer is 10. For this part, I ask myself, 3 times what number equals 6, or 6 divided by 3 equals what number? And the answer is 2. 3 times 2 equals 6. My answer, or the quotient, are those two numbers combined, 10 plus 2. 10 plus 2 is 12. So 36 divided by 3 equals 12. If I look at these two number sentences, I can see how they're part of that facts family. Here's our facts family. We also discussed last week how in a division problem, this is the dividend, the divisor, and the quotient. We also discussed how the dividend is always the largest number. So to use partial quotients, we are going to think of a multiple of the divisor, but it has to be less than the dividend. It cannot be greater than the dividend. We thought to ourselves, what multiple of 10 can I use to solve this problem? So I can use mental math, or I can write it on a sheet of paper to go one by one and think to myself, 5 times, is it 10? That's close to 235. 5 times 10 is 50. That's not close. And I keep going. Eventually, I get to 5 times 40, and 5 times 40 is 200. So I write that underneath my dividend and I subtract. I have 35 left. But I'm not done, because if I don't have remainders, I have to keep going until I get to 0. So now I ask myself, 5 times what number gives me 35? And I definitely know that fast fact, which is 7. 5 times 7 is 35. These two numbers you see here are your partial quotients. They're part of your answer. So we need to combine those two parts to get our full quotient, or our full answer, which is 47. That's how we approach all of our questions. So for 60 divided by 4, I know that I'm going to think of a multiplication problem. So I know I'm going to start with 4, my divisor, times a number. And I want it to be close to 60. So I look at my multiples of 10, and I think which one multiplied by 4 is close to 60. 4 times 10, that's 40. Okay, That's not bad. 4 times 10 is 40. How about 4 times 20? 4 times 2 is 8, and then I added zeros. 8. Oh, that's too large. So I know I'm not going to continue. My answer is going to be 10. 4 times 10 is 40, and then I have to subtract. 60 minus 40 is 20. And now I have to ask myself again, because I'm not done. I'm not at 0. 4, I'm using that same number. It's going to be my divisor. 4 times what number is going to give me 20 or something close to 20. Again, I ran into a multiplication fact that I know. 4 times 5 is 20. I subtract, and now I get 0. So where's my answer? Remember over here and over here, I have to add, I have to add these two numbers together, 10 plus 5. And my answer is 15. 60 divided by 4 is 15. Let's take a look at number 9. I see I have 735 divided by 5. So the multiplication fact I'm thinking about is what number times 5 equals something close to 735. But when I think of multiples of 10, like 5 times 10 or 5 times 20, I know that when I get to 5 times 100, my answer is only 500. But that's okay. I can go part by part if I need to. So 5 times 100 is 500. Then I have to subtract. And I'm left with 235. So I continue, and I say 5 times what number is close to 235? Again, I think of my multiples of 10. 10 times 5 is 50. 20 times 5 is 5 times 2 is 10, and one more 0, 100. 30 times 5 is 5 times 3 is 15, and that's 150. I'm still not close to 235. I'm going to keep going. 40 times 5 is 5 times 4 is 20, and then I have to add one more 0. Oh, that's getting close. Okay, let me see if I can go to 5 times 5 times 50. 5 times 50, 5 times 5 is 25, and one more 0. Oh, that's too high. I can't go past the number because I know I need to subtract. So we're going to go with this. So 5 times 40 is 200, and I subtract. My answer is 35, and I continue. Again, I ask myself, what number times 5 is going to give me 35? This is a fast fact. I know that 5 times 7 is 35. And when I subtract, I get 0. But I'm not done, because my answer involves me adding numbers together. I need to add all of these numbers together. So I can say 100 times 40, plus 40 plus 7. My answer is 147. So 735 divided by 5 equals 147.